All right, we're going to be talking about alcohols and how to name them. So, what are alcohols? They are organic compounds that possess a hydroxyl group and they end in OL. So, for example, this one would be 1, 2, 3. This would be propanol. This would be 1, 2, 3. This would be 2-propanol. And then this would be 1, 2, 3, 4, 5, 6, cyclohexanol. So now we're going to talk about nomenclature of alcohols. The suffix for alcohols is going to replace the E of the root name with OL. So hexane right here, you're going to drop that E and then add the OL to it. It is going to be hexanol. So the rest of the drill is the exact same as for alkanes, alkenes, alkynes. You're going to start by identifying what the parent chain is, the number of carbons in the parent chain, and the name of the parent chain. And then when you are numbering the parent chain, in this case, the hydroxyl group is going to receive the lowest number possible. So like for alkenes, the main group is going to be that double bond, and that should receive the lowest number possible. For alkynes, the lowest number possible should be on the triple bond. Same thing with alcohols. The lowest number possible should be on the hydroxyl because that's what makes it an alcohol. And then also we need to make sure and locate the carbonyl carbon. So the carbonyl carbon is going to be the carbon that contains the hydroxyl, the carbon that it's coming off of. And then you're going to add it in there. Just like with alkenes, you need to number where that double bond starts. It's the same reason for this. You have to number where that main group is. So step 2 is going to be identify and name the substituents, and that is going to be the exact same as everything else we've done. Number 3 is going to be to assemble the substituents in alphabetical order, and then number 4 is going to be assigning stereochem. So here's an example right here. Go ahead and pause the video and use all of those steps we just talked about and try and name this alcohol. Remember that the hydroxyl group should get the lowest number possible. All the substituents go in alphabetical order, and don't forget about the stereochem as well. So here's step 1. We found the parent chain. We numbered the parent chain going from the side where the hydroxyl will get the lowest number possible, and then we named it. So this is going to be heptan-2-ol or heptanol, 2-heptanol. And this is the exact same thing as alkenes. This is the carbonyl carbon, which is the carbon where the hydroxyl comes off of. So you need to put that carbonyl carbon either between the root name or right before the root name. The next step is to find and name the substituents. So we have 2 methyls right here, and they're both on carbon 3, so we have 3,3-dimethyl. And then we have a bromine on the 7th carbon, so we have 7-bromo. Then put everything in alphabetical order. So we have 7-bromo because the B comes before the M, 3,3-dimethyl, heptan-2-ol. And then the last thing is the stereochemistry. So this oxygen right here is going to get priority 1. This carbon right here is going to get priority 2. This carbon is going to get priority 3. And then the hydrogen is going to get priority 4. And the 4th priority is already in the back, so there's no need to flip the stereochem. And it is going to the right, so it is going to be R. So here are a few more rules that are specific to alcohols. The first one is that if you have 2 hydroxyls, the suffix is going to be diol. So in this case, you see here, we have 1,2,3, that's where propane comes from, and then we have 1,3-diol. And notice in this case that we did not drop the E. That is because it would be propanediol, which is obviously not right. So we have to leave the E just because this is not a vowel. So it would be propanediol. And then you still have to put the carbonyl carbons in there. So it's on carbon 1 and carbon 3. If a hydroxyl is a substituent, then it is called a hydroxy. So there are going to be some cases where the hydroxyl is actually not the main functional group. And you will learn more about those when you talk about esters and ketones and things like that a little bit later in the course. But in this case, the example we have is a ketone, and this is going to outrank the what would make it an alcohol. So this is actually going to be a substituent in this case. And you don't know how to name ketones yet, so don't worry about that. But it would be S because this stereochem right here is S for hydroxy, because hydroxy is this OH substituent right here, pentantuone. And the one would be because this is a ketone. I hope you found this video to be really helpful. The concepts and information presented in these videos will be true no matter what Organic Chemistry 1 class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.